Good evening. Welcome to the National Air and Space Museum's Exploring Space lecture series. I'm Matt Schindel, and I'm the curator of Earth and Planetary Science here at the museum. And it's my pleasure tonight to host this evening's discussion. This year is the 50th birthday of our museum building here on the National Mall in Washington, D.C., this building that we're in tonight. And for this year's series, we're taking our inspiration from the gravity-defying technologies that are featured in our Milestones of Flight hall. Tonight, our discussion is going to be inspired by two historic missions from the first era of lunar exploration: the Apollo lunar module that carried 12 NASA astronauts to the moon's surface from 1969 to 1972, and the robotic Lunar Orbiter spacecraft, 5 of which mapped the surface of the moon from orbit from 1966 to 1967, assisting in the search for safe and interesting landing sites for Apollo. Today, humans and robots are continuing to explore our solar system. We've just witnessed the moon again through the eyes of 4 Artemis II astronauts, and rovers and helicopters are exploring the surface of Mars. NASA's plans for the future are even more ambitious and include even more humans and robots. So we have 3 remarkable guests with us this evening to discuss how humans and robots have been and will continue to help us learn more about our place in the universe. But before I introduce our guests, I'd like to take a moment to thank the sponsors who make this lecture series possible: L3Harris Technologies and United Launch Alliance. Thank you for your support. So tonight we have 3 speakers. Håvard Grip is a principal engineer and a robotics technologist at NASA's Jet Propulsion Laboratory. He was the chief pilot for NASA's Ingenuity Mars helicopter, leading the development of its aerodynamics and flight control system and guiding the first powered flight on another planet. His work focuses on advancing autonomous flight and robotic systems that expand the reach of human exploration. Robert Curbeam is a NASA astronaut who flew on 3 space shuttle missions and holds the record for the most spacewalks during a single spaceflight: 4 spacewalks on STS-116. Before becoming an astronaut, he served as a pilot in the US Navy. And we have Valerie Neal, who is a curator emerita in the Space History Department here at the National Air and Space Museum. Before her retirement, she was responsible for the museum's human spaceflight artifact collections from the Space Shuttle era and the International Space Station. There's a lot more that I can say about our guests and all they've accomplished, and we're going to have an opportunity to get into that in much of our discussion that follows. But before we dive into our conversation, we want to just take a brief moment to highlight the museum's last 50 years with this video.
This beautiful new museum and its exciting exhibits of the mastery of air and space is a perfect birthday present from the American people to themselves.
In 1976, we opened our doors on the National Mall in Washington, D.C., taking our visitors on a journey through the sky and out into space.
Shall we touch a piece of the moon?
For the last 50 years, we have welcomed hundreds of millions through our doors, conserved, restored, and safeguarded priceless artifacts, brought history makers to you, opened new exhibitions, acquired new artifacts to document the past, present, and future of aerospace, and helped inspire a new generation of innovators and explorers. The last 50 years have been incredible. We cannot wait to see what the next 50 years hold.
So we're going to have a great discussion here this evening about robots and humans exploring our solar system. And I want to ask a few questions that are going to allow our visitors, or excuse me, our guests, to say a bit more about themselves. So I'm going to ask each of them sort of a long leading question that will help us get into that. First, I'm going to start with Håvard. So as I hinted in the introduction, the first era of lunar exploration between the 1960s and the 1970s involved humans and robots. Before we were ready to send humans to the moon, we were sending robotic missions not just to the moon, but to Venus, Mars, and other places as well. And this was the early days of robotics, so this wasn't easy stuff. But robotics has come a long way since the 1960s. Can you tell us about how you became involved in robotic exploration and how you came to be the chief pilot of the Ingenuity helicopter on Mars?
Sure. Yeah, I came to JPL in Pasadena in 2013, not really with an aerospace background. And frankly, for me, it was a little bit of just being at the right place at the right time, because this thing called the Mars Helicopter Project was just getting started up, and I was lucky enough to get roped into it and took on the role as the flight control lead for that. And I just hung on to that project because I could not personally imagine anything cooler than the prospect, even though it seemed kind of, like a crazy idea, but to fly a helicopter on Mars. And so I hung on to that, and we just kept working and working towards it, and we finally got baseline on the Mars 2020 mission, and we got to send our helicopter to Mars. And when that happened, I then stepped into the role called chief pilot for the helicopter, which basically meant operating it from here on Earth, getting to make things happen from hundreds of millions of kilometers away. And it was just the best job that I think is, for me as a roboticist, that's the best job that is possible to imagine.
That's fantastic. And Robert, 20 years ago in 2006, you were a mission specialist and a flight engineer on STS-116. This was your third shuttle flight, and you performed 4 EVAs, or spacewalks. You've spent 45 hours outside in space with just a spacesuit for protection. So during one of those EVAs, you were out there with Artemis II astronaut, with astronaut Sunita Williams as well, who folks may know. You helped to assemble and repair the International Space Station. So what's my question? Okay. Tell me what it's like to be a human being in an environment where so few humans have been, and how did you prepare for that?
Well, I was truly blessed, Matt. I tell people all the time that Uncle Sam has given me far more than I could ever give back in 2 lifetimes. I enjoyed it immensely, and when you're out on your spacewalk, a lot of people don't know it, but it's 200 degrees, 250 degrees Fahrenheit in the sun, and in the shade, it's about negative 100 Fahrenheit. So it's a pretty harsh environment, but the men and women who designed that suit were absolutely great at their job, because you're pretty comfortable inside that unless you stay in the shade for too long. And I'm really blessed to have done 3 of those spacewalks with Christer Fuglesang, who you see outside with me there, and that is New Zealand in the background. So, it was just an incredible experience, and the only unfortunate thing about that is you don't get to look around very much because you're so busy working. Every minute of your 7 hours in that suit is timed out, and you're busy doing your job. But I really enjoyed it, and you have a tremendous sense of accomplishment when you're done, and that makes it all worth it.
Wonderful, thank you. And Valerie, you and I are the historians on stage. You spent your career here at this museum chronicling the story of NASA's space shuttle program. You've published multiple books about the shuttle and NASA astronauts. What do you find most compelling about the story of humans working in space, and what do you think makes astronauts good explorers?
I would say what I have found most compelling about the astronauts as explorers is their absolute devotion to the job and their insistence to themselves that they do the very best job possible. It's said that astronauts have a sort of prayer, please God, don't let me screw up. And they believe that. And they do not want to be the person on a mission who makes a mistake, who puts the mission at risk, or who puts their own safety at risk. So I think that absolute devotion to excellence, the absolute devotion to the job itself, and to their service to the American people as our representatives out there in space, to the moon, and eventually into the solar system, is something they take very, very seriously.
And I'd like to add on to that, the other people we don't want to let down are the people who trained us. You know, there are literally thousands of people who've put in time to help you get ready for this. And it's quite the letdown, personally, if you do screw up. And so you are spot on.
Thank you. I appreciate that affirmation. Let's all take that as our motto, shall we?
Yes. And so now a question for everybody. Another long one, I'm sorry. But the objects that I curate here at the museum are mainly the robotic spacecraft that have explored the moon and explored the planets. So I know that there have been incredible advances in knowledge that these pieces of technology have contributed to. And I also know that their work is really the work of hundreds or thousands of people on the ground, making them work, analyzing their results. Putting humans on the surface of the moon, also, that advanced science incredibly with the in situ analysis of lunar rocks and soil, the samples that were brought back for analysis. They only explored 6 small bits of the moon on those missions. And rovers have only explored small portions of the surface of Mars. So what can we look forward to now that NASA is sending humans back to the moon and has this ambitious plan to send a fleet of robotic helicopters to Mars? So anybody can start.
Well, yeah, let me just start. And I think one of the things I want to say first of all about robots, right? They're tools for human beings. So you say robots are exploring the moon or other planets. It's really people exploring those places, using those robots as tools. And they just, with us advancements in technologies, allow us to do these new things where, we're now talking about not sending one helicopter to Mars, but sending 3 at a time, or sending multiple drones to the lunar surface, to explore up close. It just represents advancements in technology. It allows us to just cover a lot more ground, right? Instead of just going to one place, with a single lander examining a single spot on the planet, we can cover vast distances. For example, with these helicopters we're talking about, kilometers, in just a single flight. That's what we're looking at. And so it just represents, advancements of the tools that human beings have that allow us to sit here and explore those other worlds. And as part of that process, prepare ourselves for visiting those places and putting boots on the ground.
Mm-hmm. And what about the boots on the ground? What do you think the Artemis astronauts are preparing for in these future Artemis missions? How are they training for that?
Well, we're pretty blessed in that we have, like I said, a training team that gets you ready for everything. And one of the things they do for us is they make sure that uncrewed vehicles go before us. And that is key. A lot of the people don't remember that there were several landers on the moon uncrewed before Neil and Buzz ever got there. And that was key to making sure that we could do it safely when Apollo 11 finally came around. And what we plan on doing is using the value of the flexibility that people give you when they go to the moon. The uncrewed landers and machines and the robots, as we call them, they can do what they're programmed to do and what people like Håvard tell them to do, what they get. But once it's built, constructed, and on the surface, it can only do the things that it was designed hardware-wise to do. Okay, we can change the software, we can't change the hardware. The great thing about having humans there is when things go wrong or we find something that is unusual about the situation, those humans can then go in there, intervene, and do things that the robots may not have been able to do.
Yeah, I suppose it's that ability to kind of make split decisions, right, in the moment, and analyze things in situ there. that sort of gives humans that particular advantage. Although, robots have their own advantages too. They move slowly, but they move very deliberately, right? Their actions can be planned and rethought over time. But Valerie, with the history of human spaceflight at this point, the history of NASA's astronaut program, we've obviously learned a lot about how to safely send humans in space, how to keep them safe while they're there. How do you think these new missions to the moon will sort of take advantage of all that knowledge that didn't exist during the Apollo program?
I think we're going to see a lot of benefits or products of what we have learned during the Space Shuttle and the International Space Station era. When you think about it, when the shuttle started flying in the 1980s, our experience in extravehicular activity, let's say, was limited to just those few hours on the moon by the 6 crews who were able to land there. And they had tasks they had trained for, and they were pretty rudimentary tasks, like setting up instruments or driving a rover or just taking care of whatever needed to be taken care of in terms of deploying these things. They obviously had their own perceptual abilities and observational abilities, but the jobs they did were fairly rudimentary. During the shuttle era, we had hundreds of hours of experience operating outside the comfort and the safety of a spacecraft, not only to do things like repair the Hubble Space Telescope or construct from pieces an International Space Station that's the size of a football field in both length and width, but also to do really fine motor tasks that have been compared to doing surgery when changing out circuit boards in a scientific instrument, or removing and capturing tiny screws that you can't even handle with a spacesuit glove. And the astronauts, their trainers, the engineers, all worked on those problems, figured out procedures for those tasks, and I think vastly expanded the range of what humans are capable of doing in space. Now, I think that will continue on the moon as we continue to learn more about operating in that environment, and then those lessons learned will carry forward to eventual other missions to Mars or an asteroid or wherever the space agency and the nation decide to go.
Let me follow up with that a little bit. At a recent talk, I heard John Grunsfeld say that an astronaut can really only spend maybe about 20% of their time doing science. Most of their time is spent on all of the necessary tasks of maintaining their station or vehicle, keeping themselves healthy, and maintaining themselves in space. Do you agree with that number, Robert? 20%, does that sound about right? And as we project that idea onto a group of astronauts living and working on the moon, what does that mean about how they'll have to structure their time in order to do the science on the moon?
Well, I definitely agree that John is probably right with that number, but I think that one of the things we've learned, even in science on Earth, is that the best combination is robots and humans together. I mean, think about studying volcanoes. I don't know about you guys, but I really don't want to walk down into the, cavernous area in the volcano where the lava and magma are. But you know what? Robots do it very happily. They come back up, they bring the data up, and there are humans there on the outside, safe and sound, analyzing that data and taking it and deciding what's going to be next and what kind of new robots we have to build to do the next set of experiments. So I am all for using both. So when people ask me, do you believe in human exploration or robotic, I go, yes. You need both. There are some places where our pink bodies are just not built to go. All right, so let's do both. Let's go there together. I would feel very comfortable going on the surface of Mars and then sending out robots to explore even further away from my camp. And, you know, when they come back, see what they learned and decide where to go next.
I'm curious if I can ask you a question, actually, because with robots, yes, they can do things that human beings can't. But as we talked about before, operating them is a very sort of procedural thing. They can do a very well-defined set of things, and if things don't go according to plan, well, okay, they go into some kind of safe mode, and you have to, have to rescue them. And so everything is planned, in minute detail, and very little decision making is delegated to the robot itself. Whereas, with an astronaut, of course, it's a very different. It's very different. So I'm just curious how that affects a crewed space mission. How much decision-making authority is delegated to the astronauts versus how much is planned step by step, procedurally, ahead of time and from the ground?
I think that it really depends on the experiment and the work you're talking about. I'll give you an example. On my first space flight, it was a science mission, and we had this piece of equipment called a bioreactor, where I grew colon cancer inside of it. And I'm looking at it, and I remember doing the experiment on the ground and seeing what it was doing. And I'm like, gosh, this colon cancer is growing really quickly. And I call back down and go, we're going to have to give it more food because I'm already out of day 2 food and we're on day 1. I go, I think if we feed it more, it'll grow more quickly and we'll get some more data. And they were like, yeah, we looked at the film, I'm not an oncologist. So I go, that's just me looking at it, thinking that. And they go, yeah, we agree with you. Give it more food. And we gave it. And sure enough, the colon cancer grew about 3 to 4 times faster in my experiment than it did with the same equipment on the ground. And that's the kind of decisions you have to make that maybe the machine can't make, when we're on Mars. And we're blessed with some spacecraft that now can take the scientists with us. We don't necessarily need a whole bunch of operators in the spacecraft. We can bring more scientists, have them do the evaluation in real time, which we're going to need when we're that far away, and we're going to learn a lot more, a lot faster. But we need the robots with us so they can do the things that we already have well defined, as you said, and they're doing that while I'm doing the things that maybe we don't quite understand and need real-time decision-making. Or hopefully I've got a bunch of scientists who really understand whatever we're doing a heck of a lot better than me. I'm an operator. I'm not a scientist. I'd like to be a scientist, but I'm not. And I dare say that if we actually had an oncologist looking at that cancer while we're up there, he or she would have done a lot better at running that experiment because they would have looked at it and said, oh yeah, well, obviously that's this. And I was like, I got question marks flying over my head because I'm not a cancer scientist. So, we quickly realized we got to take more people with different skills, and we're doing the stuff that requires real-time intervention while the robots are going out there and figuring out, okay, what am I going to give to these guys to do next?
Could I respond to that a little bit too?
Of course.
Different angle. I think in the last decades, we have moved from an earlier perspective that space flight was a matter of humans versus robots to a perspective that it's humans and robots working in cooperation, each with special abilities and each with certain limitations. And what we should strive for is to find the best combination of those two. And it seems to me now that both robots and humans are programmed for exploration. You go through years of training. You know your tasks backwards and forwards. You're as programmed as a computer or a robot in terms of knowing the steps of the procedure and what to do when and all that. But I think the real distinction arises when something unexpected happens or something goes wrong. And that's when the human capability, which is much more than procedures and steps in a process, but it's your accumulated experience. It's everything you've known, everything you've done, everything you've thought about comes into play, and you have to draw upon your best judgment. And yes, you can communicate with mission control, and you can get help from the engineers on the ground, but the farther away from Earth you venture, the farther away that help is. And I think people looking ahead to eventual Martian exploration realize that the astronauts on those missions are going to have to be fully independent. They're going to have to make all the decisions themselves because it will just take too long to communicate and get help from Earth. So I'm going to be very interested to see how artificial intelligence continues to develop and what additional resources that will provide both for the human explorers and for increasing the capability of robotic explorers so this gap doesn't open up and it becomes humans versus robots, robots versus humans, but it continues to be both together, working cooperatively.
If I can pick up on that, I think this sort of dichotomy, robots or humans, it's not, it's sort of a false dichotomy, right? Because first of all, building robots for Mars or for space exploration is a very human endeavor to begin with, right? The robots are a product of human engineering, human judgment, innovations, and some dose of brilliance, some places also differences of opinion, biases, egos, all of those things kind of clash. And if a program is well managed, at the end of that, you kind of all of these things clash, and out comes like a great product, like the Perseverance rover or Ingenuity, and that's that's to me it's just like a beautiful output of human innovation. So it's a very human endeavor intrinsically. It's not primarily, or there's a lot of it is driven by facts and equations and just pure science, but there's also just a huge human component in the things that we make. And then when it comes time to operate those things, it's also a human activity, right? Ingenuity never once woke up on the surface of Mars and thought, I should go explore that area over there, or I think it would be safer to go this way than that way. It never had those thoughts because it was incapable of having those thoughts. All of those thoughts were had here on the ground, and then we told it what to do. Now, of course, we're trying, we always want to make our robots smarter, and artificial intelligence is really interesting in that context. But I still don't think of it as we want to replace human beings, right? We want to take advantage of that to do things that we couldn't do, even if we hired another 100 or another 1,000 human beings. For now, when it comes to Mars exploration, we're still on the wrong planet, right? And we're communicating to this thin straw to robots, far, far away. So if we can put some more smarts on those robots, well, then we can do things that we couldn't do, no matter how many human beings we had. So that's how I think of that potential.
Well, and what I'm hoping is we still have those robots there, and you're controlling it from the surface of Mars.
That's exactly right.
To close that feedback loop, make it a little shorter, because we're still going to need robots out on the outer edges, and they're going to be controlled by people like you, Harvard.
I wanted to jump on that because I have a question here that feeds right into that, which is, as we're now envisioning humans and robots working together simultaneously on the surface of these other worlds, does that change how you design that robot, whether it's a rover or some other type of robot operating? If there are going to be people nearby, do you make different engineering decisions?
Almost certainly the answer to that is yes. Of course that goes to safety, also just goes to interfaces. If you want things to be be able to be operated without being a deep expert in that one particular system, then you have to have interfaces that support that. So yes, I can imagine a future where we have astronauts on the surface of Mars, and they want to look over the horizon in that direction. Guess what? A helicopter is a great way to do that, and we want to make that as convenient as possible to take advantage of that.
And I would just say that probably the biggest change is you make them more maintainable. So it comes back, maybe it's broken, and you got a guy like me who says, okay, I can fix that. I fix it, and then it goes out again. Because right now, that isn't something that the uncrewed, spacecraft have to worry about, because we're not going to fix it. But it will have. That's probably, in my mind, the biggest change you're going to see. I should say the more immediate change you're going to see. They're going to be maintainable by humans, because their job is never going away. Never.
And I would like to ask you about the human experience of being a robotics operator. When you are controlling a robot on Mars, do you feel as if you're operating a video game, or do you feel as if you are present on Mars, and that robot is actually an extension of you? Or do you have some other experience of it? What is it like to operate something that distant?
Well, because of that distance, right, there's a time lag. So inherently, I think of it, it's almost like contemplating a move, like on a chessboard, right? More than a video game. You think about that one move, because you got to get that move right. You get it wrong, it's game over. And so it's really about thinking about that and thinking about all the eventualities. Now, you don't have an opponent per se, but Mars is, sort of a formidable opponent in that it can throw a lot of curveballs at you. And so it's really about trying to anticipate all the things that could go wrong ahead of time, and then carefully making a move, and then sitting back and waiting to see how that turned out. That is maybe the best description that I can give of that experience.
Chess game. I like that.
We're going to continue our discussion. I want to remind folks, if you haven't noticed, there is a QR code on the screen behind me right now. If you have a question here in the audience, use that QR code to submit your question. That will come to me here at the iPad, and when we begin the sort of Q&A portion, I will be drawing from those questions as well as the questions from our YouTube audience. So please do send your questions in. Hovard, I wanted to continue with this set of questions about operating these machines. I know that with the Ingenuity helicopter, even on Earth, even without the time delay, you can't really fly it just with like a joystick, right? The reaction time is, because of the speed the rotors are spinning, has to be a lot quicker than human reflexes. Talk about how you deal with that as a pilot.
Yeah, so I think of it as sort of a two-part process, right? One is all of the thinking that goes into developing the technology in the first place, right? Because what you have to think about then is, I'm going to eventually operate this, and so I want to give myself the best tool that allows itself to be operated the way that I want it. And so a lot of thinking goes into that. But yeah, when it comes time to fly this thing, because of just the light time itself, it makes it impossible to fly it in real time. And in practice, because we have multiple relays that the information has to travel through, it's at least a few hours, and sometimes a day or two before we hear back. And so that's why it's all about trying to anticipate what could happen, and then to use simulation tools on the ground. So we simulate flights and work with it and play with those flights and shape them until we're happy with the outcome, right? We think that we've pushed it as far as we can. It's still a safe thing to do, or there's a valid risk versus reward trade that we made here. And then it's, we just send that command up, and then, well, okay, there's, at a certain point, there's nothing you can do. It's irradiated, it's done, and you just wait.
Well, I had a question, mainly for you, Valerie. So we've talked a lot about how we operate differently, and the age of your exploration has come after mine. Can you see parallels, Valerie, in how exploration has changed from like Mercury, Gemini, Apollo, and now out to space station, and eventually Artemis, that you think we will see again as we push out and go further out, and the space vehicles change, and it's more of a combination of robotic and human? Do you see any parallels in what you saw before and changes and what we'll see out in the future?
Well, our experience of spaceflight has always been incremental. One step lays the foundation for the next step, and the experience of that step leads us to take the next step. So missions have developed with increasingly complex objectives, increasingly complex procedures, and I think that has happened whether the explorers have been robots or whether they have been humans. The first automated craft to visit other planets had a few tasks. Take pictures, let's say, maybe measure temperature. Now they can perform much more critical and detailed tasks on the surface of the moon or on the surface of Mars, subjecting rock and soil samples to really sophisticated analysis to determine what the composition is, to determine what the probable age is. Things that the earlier robots were not trained to do or programmed to do because nobody really knew how to do it yet. Same thing, the earlier spaceflight missions, the crews had relatively simple tasks. They were high-risk tasks and daunting because nobody had ever done them before, but compared to what crew members are doing on the International Space Station now, or what they did in the 2000s on the space shuttle missions, it was like exponential progress rather than incremental. Each mission kind of leapfrogged ahead and added a new capability. And when things went wrong, they learned new kinds of solutions to problems and could then plan for those so those problems didn't occur again. That I think is the nature of progress generally, that it may start out incrementally, whether you're moving from a horse-drawn carriage to an automated car, or whether you're moving out into space. You start out with small steps and then you start taking bigger and bigger and bigger steps with more complication and more payoff at each level.
Speaking of that incremental progress, for all three of you, I mean, what are you most excited to see happen next? Like for Håvard, what capabilities are you sort of dreaming of that the next generation of space robots might have?
Also, I think one of the exciting things that we're doing right now is we're kind of multiplying the capabilities and trying to drive down the cost of those capabilities and to just make them, more of a commodity. Right? This new mission that was just announced last month called Skyfall involves 3 helicopters, right? Not just one helicopter traveling on the road, but 3 helicopters that drop out of the sky above the Martian surface and then go and kind of swarm an area to investigate it so we can get a good up-close look at areas that could potentially be suitable for future crewed missions. So it's directly trying to serve that purpose of being those advanced scouts to allow us to one day put boots on the ground. And so I think part of what this is leaning into is trying to commoditize this kind of technology so that, hey, we can do this once, we can do it twice, right? We can if we want to have an up-close look at a part of the Martian surface, well, here's a way to do exactly that, to bring these robots up close. And then the other thing that I am excited about, right, is to make them smarter. As I mentioned, that will allow us just to do more with them, things that we couldn't do even if we had more people operating from the ground. I think there's a potential here. With Ingenuity, the instructions were at a very detailed level, describing exactly what each flight ought to look like. And then, you hand it over to Ingenuity to try to do the best job it can of executing that one flight. But I think the potential is certainly there with the advancements in AI to give campaign-level instructions where you say, go explore this region, like look for signs of water ice, and then come back and tell me in a week. I think that is very much possible to imagine at this point. And so I'm excited about trying to push those boundaries as well.
And Robert, what are you excited to see next?
Well, I'm on record as saying I am very much looking forward to realize we have the first humans who aren't Earthlings. I mean, you think about exploration in history, and a lot of people went over the horizon and they stayed there. They didn't come back to where they started. They just stayed there. They made their lives there. Well, I want to see humans do exactly the same thing. You know, I want to see humans that are born on Mars, live their lives on Mars, and, you know, eventually maybe even Titan, who knows? But I know we've made it when we have the first humans that aren't Earthlings.
Wow, that's maybe a few steps ahead, but I like it.
That's a lot of steps ahead, but, you know, and I probably won't be here to see it, but I hope that day comes.
What I would like to see is for humans to develop the ability to deal better with the highest risks and the biggest logistical problems of spaceflight. The highest risk is unfiltered radiation once you get outside the atmosphere. Might there be ways other than metallic shielding or being encased in a volume of water that would protect humans just as well from radiation, but we haven't thought of those methods yet? If there were, might they be simpler logistically, so you wouldn't have to have a heavier spacecraft or a shielded habitat or a habitat built underground, which I think it's not really natural for people to live underground if they're in a place with an interesting landscape. Another thing is food. Food is a big logistical challenge, food and water. Robotics don't need that. As long as they have a steady supply of sunlight and a good, reliable battery, they can go indefinitely. But humans have to have food and water. But do we have to have it in the form we're accustomed to? Or do we have to have it as freeze-dried packages of food that you add water to? Are there other ways of supplying nutrition to human beings that would not bore them to death, but would keep them healthy and fit, but not pose such a logistical challenge, something that could be miniaturized, let's say? And just, I'll throw this out as an idea, it's not appetizing, but what if you could live very well on tablets that supplied all your essential nutrients, your vitamins and minerals? Would it be impossible to live without the pleasures of real food and the sociability of dining together? Could we all just take tablets and stay healthy and well? Things like that. I'd like to see a lot more creative thought put into the ways that we remediate those risks and those logistical hurdles, because one of the best arguments for robotics is you don't have to send along a year's supply of food, and you don't have to recycle other things to create water. And they don't create waste the same way humans create waste. So let's get out of the box and start thinking about some maybe kind of science fiction or fantasy type solutions to these problems. And I think that would help enable longer and further exploration.
Great. I'm going to now start the audience Q&A. So if you haven't already submitted a question, if you're here in the audience, you can use the QR code that's behind me to submit your question. If you're on YouTube watching there, you can put your question in the comments. So I'm going to start drawing from the audience questions. And so, Robert, this first one is for you. It is, do all of the astronauts have a fun group chat? And what do astronauts talk about with each other? And I'm going to add this part. Like, do you all kind of text each other as you're watching Artemis and those types of missions? Like, can you believe what Victor just did? Like, what is that like?
That's funny. We do have group chats. I'm in 2 or 3 of them, you know, and usually it's defined by maybe where you came from, that you're all on the same mission, that, you know, you're all in the Navy. You know, there's some common thread in each of these group chats, and we talk about everything from, gosh, what life was back during the shuttle era to, gosh, they look like they're having fun on Artemis too. Would you want to go on that mission? Things like that. It's, the talk is all over the place, so, like most chats, right?
And I think this one's for you, Håvard. What fictional space robot is your favorite? And which one do you think is most plausible if it were built in real life?
I don't know. I was fascinated. I read the book by
I'm
Neil.
glad he got that one.
Well, yeah. I read a book recently by Neil Stevenson called Seven Eves, and I kind of found that fascinating because it's about humanity basically having to escape Earth in a hurry. And a big component of that is, based around, well, you have this swarms of robots that are little workers that can be put, out in harm's way and do works, and that work for human beings in coordination, right? Where you can give them high-level instructions and they carry out the task, collaborating between themselves. And that's, of course, it's a sort of a science fiction thing, but also actually not that hard to imagine. And I was fascinated by the idea, and I think it sort of fits with the model of humans and robots working together. The robots doing the things that human beings can't do, but taking their instructions from humans. So I thought that story I really liked. There isn't one particular robot, but rather that swarm of robots in that book I found resonated with me.
I'm going to send this one to you, Valerie. And I want you to answer it just based on all of your research on the years of shuttle missions and ISS missions. So we heard a lot about the advantages of human astronauts via problem solving and flexibility, et cetera. But what about the more intangible elements like human connection? Is there more general interest in crewed exploration because there's that element of human stories, connection, risk, and accomplishment? When you're writing your books, is that something that you think people really are drawn to?
Absolutely. Most people would say what makes a long-duration mission livable and successful is the people you're with. And most of them train together, but there are always some people who come from another country, let's say, or who have already been in space for several months together, and they've formed their bond, and now you're the newcomer arriving in their midst. And it's all about working cooperatively, being sensitive to one another. And everybody says that mealtime is so important, dinner time. So far in space, on the space station and on the shuttle, people tend to eat breakfast together, grab lunch when they can, but they always make a point of having dinner together, and that's when they relax. They tell stories about their families, they talk about what they're concerned about, and that sort of thing. And the astronaut, Mark Kelly, I always get them mixed. Mark Kelly, who spent a year on the space station, wrote a book about it called Endurance. And there were points in that year where there was a little bit of friction among the crew. And it definitely affected morale, and it affected their ability to get the job done. So I would say that human element of knowing, liking, respecting the people you're working with, and not getting bothered by little things. Because if you get bothered by the little things, you're never going to make it through a whole year. You have to let those little things go and find a way to deal with them that doesn't create tension or that doesn't break the bond you need to have to do the job successfully. And I'm sure Robert can comment on that much more authentically than I, because that's what I know secondhand, but you know it firsthand from 4 different crews, right?
We're people, right? So you're going to have people that don't get along. You're going to have people that get along, and even the people you like the most are sometimes just going to get on your nerves. I'm sure all of my crewmates can tell you a time when I got on their nerves. If it was, and Navy Air Force football game that we were arguing about, or, who knows, F-14s versus F-15s. There's always something that you can bother each other about, and sometimes you're doing it on purpose, sometimes you're just doing it accidentally. But, that's always going to be a part of it because we're humans. But as you said, Valerie, at some point you got to get over it and say, hey, we got a job to do.
Great. We have some more great questions here. This one is about the Ingenuity helicopter. What did you learn while piloting Ingenuity that will be incorporated into the Skyfall or Dragonfly missions? So sort of what are the takeaways of the lessons learned from that?
Honestly, when we flew Ingenuity, I was surprised in sort of a positive way by just how operable this technology was. We imagined we would fly up to 5 times, but for being honest, if we took off once, we would be jumping with joy. It was, that would have been amazing. And but we landed on that first flight, and then we kept flying, for 72 times. And so at the end of it, I honestly surprised myself by just I found that I went from thinking this is a neat accomplishment of we can prove that we can fly another plane to this is more than just a toy. Like, this is a real tool that we can really put to work. And so I think based on that, we've just become a whole lot more confident in what this technology can do. And that's frankly why we can do something like jump out of a parachute when you're still heading towards the ground at pretty fast clip, is because we've just learned that this technology is actually quite robust, and it's time to kind of take the training wheels off and really embrace it and make the most of it.
I'm going to jump right back on that because there's another question that relates to this, which is, in terms of the ways that we tend to anthropomorphize robots, did you develop a sort of attachment to Ingenuity? Were you sad when it stopped operating?
But see, I think I'm different from a lot of people that way, because a lot of people actually, I think, have exactly that. They refer to it, as she and Ginny, and they anthropomorphize the robot, and it's not just Ingenuity, but other robots too. And I've never developed that kind of relationship to a robot. I think of it as a machine, and sort of what comes to mind is I see the fingerprints all over that machine of all the people who actually worked on it, right? I can see the fingerprints of Sarah and Ryan and Bob, and I know how their inputs affected that. That's really what I think about. But at the end of the day, no, it's not a personality. It's just a machine, and I was not sad when the mission was over. I thought it went out with a bang in exactly the way that it should. It just went out exploring Mars and pushing the boundaries.
This one's for Robert. You were a pilot, a Navy pilot, before you became an astronaut. How did that help you in becoming an astronaut? And were there any things that you had to unlearn from your time as a Navy pilot when you became an astronaut?
Just to be clear, I was a radar intercept officer and proud of it. No, so if you've watched Top Gun, I was Goose. That's what I did for a living. And I think the thing that helped me is I learned while I was doing that job in the Navy that it's very, very important to have a short memory when things are going wrong and a long memory when you got to fix something. And what I mean by that is when you screw up, you got more things to do. So you got to let that pass, forget about it, and get on to the next thing and do it well. And then the long memory comes when things are going wrong consistently and you got to fix something. And it's like now you got to reach back into that bag of tricks that the trainers taught you, or your knowledge of the systems on board the spacecraft, and go, hey, they taught me how to fix this, but this ain't that. This is something similar, but not quite. And that came to fruition when we had the ammonia leak. The engineers told me, you may get an ammonia leak, and this is how you fix it, but don't worry. Only the female attachments will leak, not the male attachment. It's designed so it can't leak. So what do I get? A male valve leaking. So now it's like, heck, well, all that emergency training is out the window. How do I fix this damn thing? You know? And that comes to knowing the system, knowing where the upstream valve is. How do I close it? How do I get to it? What do I do when I get there? You know, and then after I close it, what else have I screwed up in the system now that I'm going to have to go back and fix? So, I mean, that's what you have to be able to do. And that's got to be unemotional, and it's got to be, hey, this is what's important right now. I'll get to all the rest of it later.
By the way, what we're seeing in the images there, you're attached to the Canadarm, right? So that's a great human-robot collaboration right there, right?
And that is an example of things going wrong. When they tried to retract this solar array that you saw, for those of you who still remember road maps, sometimes they used to fold the wrong way, and when they did, I should say, they didn't collapse all the way. Well, that's what happened with this. So they put me on the Canadarm and took me out there, and we had ginned together some different tools, taped them together, and then covered them in Kapton tape, which was non-conductive, thank goodness. And then they sent me out there to take it and, you know, make sure that the solar array folded in the proper way. And we did that for several hours until it folded all the way up into its blanket box. And, you know, like I said, once again, the long memory, because you got to fix something. What's dangerous to touch? What can I touch all day long? What's important to keep alive so that when they, you know, keep intact, I should say, so that when they want to deploy this again later on, 4 flights down the road, it'll still work. What can I cut because I know they're never going to use it again? Stuff like that. So like I said, when you're fixing things, you got to have a long memory to think back about all those things they taught you, you know, over one day out in Sunnyvale, you know, when you got your one look at a solar array, and that all that has to come back, and it better come back quickly.
Let's see. Maybe Valerie, you might have an answer to this, but others may as well. What technological advancements since the end of the shuttle missions do you think is going to be most impactful, or maybe already is most impactful to astronauts that are flying Artemis or who are, you know, flying to the ISS today?
I couldn't tell you. I don't know.
That's fine. I totally respect that. Let me ask you a question then more related to you as a museum curator. What's the highlight for you on this job of collecting artifacts or meeting people who are, you know, part of that story of human exploration?
Well, I have to say, every day had its highlights, but over the course of 30 years, I think the pinnacle of my career was when this museum acquired Space Shuttle Discovery to bring it into the collection and put it on display at the Udvar-Hazy Center. There had been so much desire to collect a flown-in space shuttle. Discovery was the one we decided we wanted, but we were part of a process that we had no control over because NASA was making the decisions where the shuttles would go. And so when we finally received word that Discovery would come here, then we kicked into planning mode and we created a whole week-long celebration called Welcome Discovery that included inviting the public out to watch it fly into Washington, D.C., and it made big loops around the mall 3 times, and then it landed at Dulles Airport. It took 2 days to get it over to our property, and we had a wonderful ceremony that day with the Marine Corps Band and John Glenn and other dignitaries, and we invited all of Discovery's commanders to come to that ceremony, and almost all of them were able to. And it was just so festive. It was such a wonderful accomplishment for the nation's capital. and for the Smithsonian and for our museum in particular. I don't think anything will ever top that unless I get to go to space and stay in orbit.
That's great. We are now out of time. We can't take any more questions, but I want to remind you all that our next Exploring Space lecture, Return to Venus, is going to take place on May 7th. Registration is open now, so if you'd like to come, please reserve your ticket. Stargazing is going to take place outside over by Delta Solar, so just head out the Independence Ave exit as you leave the museum. Walk towards... I think I've lost my mic. Can I borrow yours? Is this one on? Is this one on? All right, there we go. Walk towards 7th Street, and our astronomy team will be waiting for you. We always want to hear from you, so if you could take a few minutes to complete our lecture survey, we'd really appreciate that. The QR code is behind me right now. And thank you. Thank you all for coming. Thank you again very much to our sponsors, L3 Harris and United Launch Alliance. Again, you all make this possible. And, please come back again. Come for our May lecture. Come to our other events. We always love having all of you here in the museum. Thank you. And thank you to our guests.